Okay, in this lesson we are going to introduce you to combinations, and this will be the part 1 of combinations. So I'm on page 95 of your workbooks. So let's look at a little scenario here. So as part of the grade 12 English course, students are required to read 3 books over a 3-month period. So the Grapes of Wrath, the Wars, and the Bean Trees. You can abbreviate these using B, W, and G. So Steve, unfortunately, has returned his books late, so he can't take out all 3 books. He has to sign them out one at a time. So I want to come up with all the different ways that Steve could sign out the 3 books. So let's start with the bean trees. So just use a B for that. He could do B and then W and then G. That would be one possible order. Or he could still sign out the bean trees first, but switch around the order here. Okay, now let's say he signed out the wars first. Well, he could sign out the wars, and then the bean trees, and then the grapes of wrath. Or he could also still sign out the wars first, but switch around these books. And then the last set of options is he signs the grapes of wrath first, and then the bean trees, and then the wars. Or still signing out the grapes of wrath, just switch these 2 around. So those are all the different possibilities of signing out the 3 books. So I can see that there are 6, but I know using my factorials that there are 3 factorials or 6 ways of signing out all 3 books, signing out 3 books one at a time. Now let's compare doing them one at a time to Tariq. Tariq is allowed to sign out all 3 books at the same time. How many different ways can he sign out all 3 books? So he goes into the library and these are the 3 books he has. So he's signing them out all at the same time. So it doesn't matter if the librarian gives him the books in these orders, or maybe the Grapes of Wrath is on top, or maybe the bean trees is on the bottom. It doesn't matter because he's grabbing all 3 books at the same time. So there is only one way to sign out all 3 books at the same time. So let's compare those 2 together. What we did in part A, signing them out one at a time, is a permutation, because in a permutation, the order is important. Whereas in part B, where he took out all 3 books at the same time, that would be a combination because order is not important. So this will be a new concept that we will be looking at. What happens when the order is not important? And that is a combination. So let's look at this from a different angle. So in this one here, let's say that they're required to only read 2 of their books. So of the 3 books they have, they read 2 of them. So I want to look at the different ways which Steve and Tariq could do this. So Steve could read Grapes of Wrath and then sign out the wars, Grapes of Wrath and then the bean trees, the wars and then Grapes of Wrath. He could do the wars and then the bean tree, Grapes of Wrath, bean tree, and the wars. So for Steve, the order is important because he's only signing out 1 book at a time. Now Tariq was allowed to have all of his books at the same time. So him reading Grapes of Wrath and Wars and the Grapes of Wrath, for him it's just he's reading the Grapes of Wrath and then he's reading the Wars. So those 2 are the same idea. Same thing with these, because he has all his books, so he's just reading 2 books. So here, Bean Trees and Grapes of Wrath would be the exact same. It would be a doubling up. So it's kind of like permutations with repetition. Okay, and then this one here, the Wars and the Bean Tree, is also the same. So Steve has 6 different ways of reading 2 different books. And let's think about that with fundamental counting principle. 3 choices for my first book, 2 choices for my second book is 6. But Tariq only has 3 different possibilities because the order is not important. So since the order is not important, we can take the permutations, 6, and divide it by the ways of arranging those 2 books, since order doesn't matter. So I'm dividing by 2 times 1, or 2 factorial, and that's why there are only 3 different combinations for Tariq. So just to recap that, the number of combinations is equal to the number of permutations divided by 2, or 2 factorial. So the reason I did 2 factorial is because the order of the books doesn't matter, and there are 2 factorial ways of selecting 2 books. Okay, so looking at this here, permutations of 2 objects taken from 3 is 3 times 2 is 6, or 3p2, but the combination is the permutations divided by the ways of arranging it. Or there is a button on your calculator, which is C for combination. We could do the combination of 3 objects taken 2 at a time. So the reason we divide by the arrangements is because the order doesn't matter. So this is going to be a key idea for us. Does the order matter or does it not? So just to recap what we've done so far, a permutation order is important. So if I have 3 letters A, B, and C, there are 6 different permutations because switching the order around makes a different word. Combinations, order does not matter. So there's just one combination of the letters since all of them are really the same. So the biggest trick in this unit, once we get finished the unit, is when I give you a question, how do you know if it's a permutation or a combination? So I have like a little preliminary list here to start us off, and we can add to this list as we go through the chapter. So permutation, all of the objects are considered to be distinct or different. We are arranging objects. We are assigning jobs, roles, positions, or tasks. Combination, everything is considered to be alike. So we're just choosing objects or selecting objects. There's no jobs, roles, positions, or tasks. So everything is just ABC, same as CBA. The order doesn't matter. So let's look at an example here. So we have 5 different students, A, B, C, D, and E. They're taking part in a cross-country race to represent their school. Now let's say that the winner of the race receives $50, the runner-up receives $25, and the third place wins $10. So we're going to look at all the different ways we could award 3 prizes to 5 participants. So because I have ordering there, first place is different than second place is different than third place. So this is definitely a permutation because there are positions. So anytime you hear kind of like a ranking system, first, second, third, president, vice president, that is a permutation. Okay, so I want to know how many ways are there to award 3 prizes. So you can see we've listed them all out there, so you could just count them, or you could put this into your calculator. So using the fundamental counting principle, there are 5 choices for first place, 4 choices for second, 3 choices for third place. Or you could look at the permutations, that's why I'm using a P, of 5 people taken 3 at a time. So either one of those would be correct and it would give you 60. And you can see them all listed out there. Now let's say instead of awarding first, second, and third place, I say, okay, I'm going to just choose 3 students from people that took part in my cross-country race. So I have all of the different ways that they could finish first, second, and third, but I'm just going to select 3 people. Doesn't matter who was first, second, third, fourth, or fifth. I just want to select 3 different people. Okay, so what I want to do is look at this table and get rid of all the duplication. So if I look at this table here, I can definitely see that there are some doubling up. So if I want to choose students A, B, and C, that's the same as choosing A, then B, then C, or A, then C, then B, etc. So everything below that heading is crossed off because the order that I'm selecting the 3 students doesn't matter. It just matters that I'm selecting them. So this would be an example of a combination because I am selecting 3 students. There's no positions, there's no first, second, third place, there's just selecting the students. So the ways of doing that, we can see there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different ways of doing that. So because it is a combination, we can use that combination button on our calculator. So we can say that the combination of 5 students taken 3 at a time is in fact 10. So you can see them all listed out, and here's how you would do that on your calculator. So the number of combinations is equal to the number of permutations divided by, and we're going to divide it by 6 or 3 factorial. The reason I'm dividing by 3 factorial is because the number of ways of arranging all the objects doesn't really matter. It's not a first place, second place, third place scenario. So putting this all together, the number of combinations of objects. So combination of n objects taken r at a time is just the number of permutations divided by the ways of arranging those objects, since order doesn't matter. So this formula is on your formula sheet, and you can see right there the formula is found by taking the permutation divided by the ways of arranging the objects, and that's how we get this formula, and this is on your formula sheet. Now what I do want to mention is the diploma likes to use an alternate way of writing this, which is also on your formula sheet. So NCR is the same as, when I have brackets, N and R. So they are in round brackets. I want you to avoid the temptation of putting a fraction there because it's not a fraction. This is just a notation. And this just means the number of combinations of N objects taken R at a time. So these notations here are the same. So sometimes you'll see this one here creep up on the diploma from time to time, but it is also on your formula sheet. So let's look at a little shortcut to finding combinations. Now keep in mind you can still use your calculator to do this. So let's say I wanted the combination of 8 objects taken 3 at a time. So all I'm looking at is the permutations on the top. So 8 choices for my first, 7 choices for my second, 6 choices for my third. Now, since it doesn't matter the order that I'm doing this, I'm going to divide by the ways of arranging the 3 objects that I picked. So the 3 objects that I picked have a 3 factorial, or 3 times 2 times 1 way of arranging them. And the reason I like this is because it's a lot quicker to do, because if I have 6 on top, 6 divided by 3 times 2 is 6, I'm just left with 8 times 7. Which is 56 ways of having 8 objects and taking them 3 at a time. So that's a little shortcut that you can use writing it out, but there is also the calculator button. So the same place that we went for factorials, permutations, is the same place you find the combinations. So for those of us with the TI-83 or TI-84, you're going to go into your math function, go all the way over to probability, and really it's these options here that we're going to be working with this whole chapter. So this was our permutation, this was our factorial, and right in between those, option number 3 is the combination. So that's how you enter it into your calculator. For those of us that have the color calculator, we can use our alpha window. So alpha window 9 was option for factorial. Alpha window 8 will be your option for combination. So let's try a question. 3 students from a class of 10 are to be chosen to go on a school trip. How many ways can they be selected? So let's first of all write it in factorial notation, and then we're going to confirm that using a combination. So 3 students from a class of 10. So I'm only picking 3 students. So I'm going to look at 10 choices for my first, times 9 choices for my second, times 8 choices for my third, and I'm going to divide that by 3 factorial. And the 3 factorial is the ways of choosing those 3 students. Okay, so I can enter that into my calculator, and in doing so I would get 120. Okay, we've done lots of those before. This is new though, dividing by the 3 factorial. Now let's say I wanted to enter that in using my NCR notation. It is a combination because I'm just selecting 3 students. I'm not saying first place, second place, third place. So I'm going to look at the combinations of 10 students taken 3 at a time. So in doing that, I punch it into my calculator, and you can see I get the same answer. So this is nice because you guys have a choice on how you want to do it. You can do it using your fraction and factorials, or you can do it using your 10CR button. So remember, for fundamental counting principle, I said I really like to do permutations using that. Combinations, I kind of like using the button because it's a little bit quicker. but you choose whichever way that you want to do it. Let's try another example. So we have this lotto system called the 649, and I just want to explain to you why it's called a 649 if you've never heard of it. It's called 6 because you are choosing 6 numbers, and 49, you're choosing 49 numbers from 1 to 49. So you can go in and you can actually pick the numbers that you want to, or you can do what's called a quick pick, and it randomly selects numbers for you. Now, let's say that you do what Jasper did. He selected birth dates from his family. So he selected these numbers here. Now, when they pick the numbers, if those are the numbers he selected, he would still win the lottery if the numbers picked were in this order. So for lotto tickets, the order does not matter for this particular lotto system. Okay, so it's a combination. So I'm going to look at the combination of 49 numbers taken 6 at a time. And I punch that into my calculator and I get this really big number. It's almost 13.9 million. So that's how many different combinations there are to win the big lottery. So best of luck to you with lotteries. I know my odds are not in my favor, so I'll put my money in the bank. Let's look at class example 3. Okay, an athletic council decides to form a subcommittee of 7 members. So I'm needing 7 members altogether. I kind of like to summarize it on the side so it makes it easier for me on how funds raised should be spent on sport activities. So there's a total of 15 athletic council members. 9 of them are boys, 6 of them are girls. The subcommittee is going to consist of exactly 3 females. So exactly means no more, no less, exactly 3. Now, important to note that this is a combination, not because it's a committee, but because it's a committee that doesn't have jobs or positions. So I'm not saying I'm choosing a committee where I have a president, vice president. I'm just choosing a subcommittee. So order does not matter. Okay? So I want to look at all the ways of selecting the females. So this is where I'm going to go to here. There are 6 females and I am selecting 3 of them. So I can put that into my calculator and there are 20 ways of doing that. Let's look at the ways of selecting the males. Okay, I want 7 members on the committee. So if I want 3 females, that means I want 7 males. So looking at the males, there are 9 males and I'm taking 4 of them. So 9C4, and I put that into my calculator, I get 126. So now that I've got the ways of selecting the males and the females, I want to look at selecting the subcommittee. And the subcommittee has 3 girls and 4 boys. So I'm taking my answer from the first part for the girls, 20, and then 126 for the boys, and I multiply those together because remember in math, and means multiply. Okay, so there are 2,520 different ways of selecting that subcommittee. Now, next question. How many ways can the subcommittee be selected if Bruce, the football coach, must be included? So let's look. So back over here for our committee, we had 6C3 for the girls, 9C4 for the boys. So I'm just going to write that out. 6C3 for the girls, and then 9C4 for the boys. So that's what we did before. But I want to make sure that Bruce, the football coach, must be included. So my girls, they're good to go. My boys, since I want to make sure Bruce is on the committee, I'm not choosing from 9 people anymore. I'm choosing from 8. And since Bruce has to be on the committee, I am not choosing 4 boys. I am choosing only 3 because it's really 3 boys plus Bruce. So we're ensuring that Bruce is on the committee. Okay, so I can multiply those together and then I get my final answer of 1,120 different ways. Okay, let's look at card questions. So card questions, on the diploma, they will lay everything out just like they did here. Like they'll tell you how many suits there are, how many there are in each. That's why on my formula sheet, I always have those cards laid out on my formula sheet. So you can see that this is the picture that I have on my formula sheet, just to help you guys visualize it. But don't worry if you're not a card person. The diploma will always explain it to you. Now, card questions without fail are always going to be a combination question. Okay, so that's really, let me just line it up there, sorry. That's really important to note. So card questions will always be combination, because as soon as you get your cards in your hand, you can shift them around. Okay, so that's why card questions will always be combination. So we're going to go through and answer a bunch of these questions here. So we have 52 cards in the deck. All the characteristics are listed out to you. And we want to know how many different 5-card poker hands are possible. So to do this here, we have 52 cards in total, and we're going to look at the combination of taking 5 of them at a time, because poker has 5 cards in the hand. So it's going to be a big number. So put that into my calculator, and I can see it's 2,598,960 different 5-card poker hands. So now we're just going to look at some different variety questions here. Okay, next question says, how many of the cards will be all diamonds? Okay, so you can see, and I've highlighted it for you, there are 13 cards in the deck that are diamonds, which means there are 39 cards in the deck that are not diamonds. That's why I did diamond prime. Okay, but we want all diamonds. So we're picking from 13. So I have the combination of 13 cards taken 5 at a time, because I want them all to be diamonds. And you can see the more restrictions I put, the less combinations there will be. Okay, next question says, I want to know how many 5-card hands have 4 black cards and 1 red card. Again, that and means multiply. So you can see how I highlighted it here. There are 26 cards in the deck that are black, 26 cards in the deck that are red. And I want 4 black cards. So of the 26, I want 4 to be red. And of the 26, I want 4 to be black. I said that wrong. 26 cards in the deck, I want 4 to be black. 26 cards in the deck, I want 1 to be black. And I can multiply those together, and I get 388,700. Okay, let's try another one. How many 5-card hands have 3 kings and 2 queens? So you can see I highlighted it here. There are 4 kings in the deck and 4 queens in the deck. So of the 4 kings, I want 3 of them. Of the 4 queens, I want 2 of them. So I can just multiply those together, and I get 24. So again, the more restrictions I put on things, the less combinations there will be. Okay, so this next question says, of the cards in A, which is the 5-card hands, how many will there be 3 kings? So again, you can see I highlighted there are 4 kings and 48 not kings. Now the big key here is that I need to add up to 5 cards in my hand. So I need to remember we always have 5 cards in my hand. So if I have 3 kings, that means I have 2 not kings. So let's look at the ways of picking the 3 kings. There are 4 kings in a deck. I want 3 of them. Now I have to look at not kings, because I don't want to have another king in there, because then it would be 4 kings. So there are 48 cards in the deck that are not kings, and I want 2 of them. Okay, so I like the pictures there and highlighting them, because then you can really see what we're talking about. And putting that into my calculator, 4,512. Okay, the next question, I have 4 aces. Again, remember you have to have 5 cards in your hand. So you can see I've highlighted the 4 aces, and there are 48 not aces in the deck. Okay, so this is what we're going to be looking at. 4 aces. I want all 4 of them. So 4, C4. And then I have 1 card left, and I don't want it to be an ace. So there's 48 not aces, and I want 1 of those. So multiplying that together, I get 48 different 5-card hands. Okay, in our next question here, we're saying how many of the cards, the 5-card poker hand, will there be a flush? And what a flush means is it's all cards in the same suit. So it could be all spades, all hearts, all diamonds, all clubs. Okay, so this is what it would look like. All my cards could be clubs or spades or hearts or diamonds. Remember we talked about this, or in math means add. So let's look. There are clubs, there are 13 of them, and I want all of them. Or 13 spades, and I want all of those. Or 13 hearts, and I want all of those. Or diamonds, there are 13 of those, and I want 5. So I can plug it into my calculator like that, and I get 5,148. Or you can notice these are all the same. 13C5, 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 13C5. These are all the same. So you could enter this in as 4 times 13C5 instead of doing it all individually. But either way honestly is fine, and you can see that I do get the same answer altogether. Okay, so this is our introduction to combinations, our part 1 lesson. So the big thing that I want you to know, and even when we're moving forward, I know we're dealing with combinations, but every single question I'm going to talk to you about, is the order important or not? Because when you're done the chapter and you're writing a test or a diploma, everything will be mixed up. So again, permutations, order matters. That's the big distinction, because combination orders does not matter. So to figure out combinations, since the order doesn't matter, we take the number of combinations. To figure out the number of combinations, we take the number of permutations and divide by the ways of arranging the objects. Okay, I have just a little list here of some of the common combinations. If you have n objects and you want to take all of them, there's only one way of doing that, taking all of them. If you have n objects and you want to take one of them and order doesn't matter, there are n ways of doing that. And if there are n objects and you want to take none of them, there's only one way of doing that. Again, you can still punch things into your calculator, but this is just to save you a little bit of time. Okay, so you know when you go to your locker in between classes, how you enter in your combination. I want to start a fad. I want to start something. I think we can totally do this, because if I don't enter my combination in the correct order, I'm not going to gain access. So I want to, moving forward, instead of calling them combination locks, I want to call them permutation locks. And I think you guys are all the students to help me with that. We can start a new movement. Let's call them permutation locks. Okay, so for practice questions, I want you guys to do questions 1 to 12. Again, I have all my detailed solutions on D2L that you can look at. And that concludes our first introduction to combinations.